There, Advanced Math. Gonna keep working today on solving algebraic equations here. And we're gonna add parentheses into the mix today. Changes it up a good bit. So find your next free page and make this the title on that page. After you've done that, close it up. Give me your total concentration. So we've been working on solving for a variable in an equation like this, and it seems to always have the same two steps. Something's being added to x, and something's being multiplied by x. In this case, we're adding 7 and multiplying by -3. And with the inverse operation strategy, we did the opposite operation of each of those and in the opposite order. So I would start with my addition and subtraction. So the opposite of adding 7 was subtracting 7. And we got -3x equals 2. And then we did the multiplication second, or undid the multiplication second. So the opposite of multiplying by -3 is dividing by -3. And I get x equals 2 divided by -3 is -2/3. So x equals -2/3. And we've done a bunch like that, and it's like we do the same steps like every time. So I'm going to take this exact same problem, but I'm going to put parentheses here today. Like this. And see how that changes the problem a bit. Oops, I already had to start over once and I forgot to erase everything. So let's take care of that. Okay. So I want to show you two different ways to attack this problem, so that you have some choices. So the first is just to stick with gems in reverse order. So if I do that, I change what I usually do. Usually I would deal with the +7 and then the multiply by -3, just like I did in the last problem. But the parentheses change thing, because really then what I have is multiplication, which I'm going to do first. And then I have parentheses, grouping symbols, which I'm going to do second. The parentheses change, even though I would normally do +7 first, since it's in parentheses, I have to do the grouping symbols last in reverse gems order. So that's kind of my plan there. So if I do -3 sets of x plus 7 equals 9, then my first step is going to be to deal with this times -3. So the opposite of times -3 is divided by -3. So I'm going to divide both sides by -3. And now here's, this is where I wonder if you're going to like this strategy, and why I'm going to offer you a second one, is this gets kind of weird. I take -3 divided by -3. Remember, first thing, we do that in algebra to get rid of these. So this, the whole point is that these are going to go away when we do that. The reason is -3 divided by -3 is 1. So instead now of having -3 sets of x plus 7, I just have one set of x plus 7. So I'm not sure if that step makes you uncomfortable. That's why I divided by -3, is to make only one set of this instead of -3 sets. And then that's how it looks. I don't have to write the one. So -3 divided by -3 gives me one of these. So now I've done this step. I've kind of undone that operation. And 9 divided by -3 is -3. So now I do the parentheses. So in the parentheses, I have +7. And the opposite of +7 is -7 from both sides. And now I'm going to get x equals -3 minus 7. Which I need to go and work out. -3 minus 7. If I add the opposite, that is -3 plus -7, which is -10. So I get x equals -10. So again, reverse order. Multiply first, or undo the multiply first, then undo the operation in the parentheses. So if you don't like that, and that seemed a little uncomfortable doing them in the wrong order, or because we were dividing with parentheses involved, you can also do a strategy I like to call distribute first. And if you distribute first, you'll get the same old kind of problem you've always been working with, and you may feel a little bit better about that. So when I write this problem down like this, back to the beginning, you'll notice I have a chance here to use the distributive property. I have a number of times a sum, and I can use the distributive property to rewrite that as -3 times x plus -3 times 7 equals 9. So I took this expression on the left-hand side and I just rewrote it like this. And now this is the same old kind of problem we've always been doing, right? Something times x and something plus x. And we've done a ton of those. So if you want to, you can just use the distributive property, and now you have a very familiar problem where I have my usual things to do, where I have times -3 and I have plus -21, and I just do those in the familiar reverse gems order. I will do this first and this second. So undo my opposite of plus -21 is minus -21. -21 minus itself is 0. And minus -21 on this side. So now I have -3x equals 9 minus -21. 9 minus -21. Add the opposite, that is 30. So now I've done this. I've undone my first operation, and I have to do my second. The opposite of times -3 is divided by -3. And I get x equals -3. 30 divided by -3 is -10, which conveniently is what I got over there. So you can either do reverse gems order and just keep the parentheses and not be scared of them, or you can distribute first, do the distributive property, and then do the same old kind of problem we've been doing for a while. Either way works. Let's do one together. Let's look at this guy. So, look it over first. There's a fraction in it and some negatives, nothing to be worried about. So my first strategy is to just do these in reverse gems order. And just know that it's not going to be your usual set of things. I have multiply by -4. And I have parentheses. So in reverse gems order, I would do the multiplication first and the parentheses second, opposite of what I'm used to doing. So -4 times a plus 3/4 equals 10. All right, so if the opposite of times -4 is divide by -4. On both sides. So the reason I did that was to get rid of this, right? I had -4 sets of the parentheses. If I divide that by -4, now I just have one set of the parentheses. Okay? And then 10 divided by -4, I'm going to take the easy answer is -10/4. Could probably convert that to a decimal, or you could mix number, but that's the easiest answer. 10 divided by -4 is -10/4. So now I've done my first step. Now I do the parentheses. They're the second thing in reverse gems order. So inside the parentheses, I have plus 3/4. The opposite of plus 3/4 is minus 3/4. And minus 3/4. And that'll make 0, and I'll get a equals, let's see, -10/4 minus 3/4. Got to be careful with your signs here, right? And that is, if I add the opposite, negative 10/4 and negative 3/4 would be negative 13/4. Or if you're not comfortable with that, negative, 4 times 3 is 12, 3 1/4. Either way. All right, so that's my first way to do it, is just stick with reverse gems order and just be okay doing things out of order. In this problem, I think that one's going to be easier because I only had to deal with this fraction one time. When I distribute first, I'm going to have to deal with the fraction 2 times, possibly, which could be a little tougher. So the other way to do it is called distribute first. If you don't like this strategy too much, then what you can do is start out by doing the distributive property on this side. And you'll get a more familiar looking problem. Negative 4 times a is negative 4a. Negative plus negative 4 times 3/4 is negative 12/4. Remember I said you have to deal with the fraction twice? I actually got lucky because I can make this not a fraction. I can just make that be negative 3. But if you don't like fractions, distribute first, I would have had to multiply by the fraction and then subtract it later, which could have been a little tough. But I lucked out and I got a whole number. So if you distribute first, now look, you've got the same old problem we've always been doing. Add something and multiply something. And you just have to undo them in the right order. So my first step there, let's see, you can write this is familiar. That's why we did it. So my first step, the opposite of plus negative 3 is going to be minus negative 3 on both sides, minus negative 3. So negative 3 minus negative 3 makes 0. And 10 minus negative 3 is add the opposite 13. And then the opposite of times negative 4 is divide by negative 4. And 13 divided by negative 4 is negative 13/4, which is what I got over there. So that's it. So 2 ways to do it. They both work just fine. It's kind of a matter of just which one you're more comfortable with. Please do me a favor. This was a lot to learn in one lesson because we had all these negatives and fractions in addition to the parentheses floating around. So please make sure you feel really good about both these examples before you stop. Don't just stop because it's done. Keep going till you really understand this, and make sure you're ready to be a great partner when you get here tomorrow, okay? So once you totally get this and you've got both this example well and neatly written down so that you can learn from it again in the future, if you forget, you're all set. See you tomorrow.